Suppose that I have a tiling pattern on the floor. This is when you have a floor which is hard and you put these ceramic tiles on top of it. You can make very nice patterns. Actually, in many areas in Europe from the older times, there are beautiful floors with these kinds of patterns on them. This pattern is one where it looks like there are strips of black in a pattern where there are white spots in this grid around them. Suppose this is what the pattern looks like when you have 7 by 7. Here you see 1, 2, 3, 4, 5, 6, 7. The question is asking, if I have 57 by 57, how many white tiles do you need? Let's see. And I promise you there will be a fun surprise at the end as well. The key observation here is to see that the white tiles come in their own grid pattern. For example, whenever you're doing a problem, especially if you can look at a case, a smaller case, you might see a very nice observation. For example, in this 7 by 7, the number of white squares is 4 times 4. So the number of white squares in the 57 by 57 will also be something times the same thing. But how much? What's the relationship with the 4 here? On this picture, the number of white tiles is 4 white tiles. Look in the columns. 4 white tiles and 3 black tiles, if I look at one of these rows. So the relationship between 4 and 3 is that 4 is about half of 7. In fact, 4 is half of 7 rounded up. Let me share with you a little bit of notation, which sometimes we use when we write this down. We take 7 divided by 2 and round up, and that's 4. If you ever see anyone write this down, this means that you calculate the number and then you round it up. And now I just need to do the same thing for 57. I see 57 is odd, and so that will be 58 divided by 2, which is just 29. So that means that the answer to the whole question will be 29 squared. So far, it looks pretty routine. And actually, calculating the answer is pretty routine. I just need to take 29 times 29. And if I take 29 times 29, 9, 9 is 81. 9, 2 is 18. 26. 2 times 9 is, there'll be an 8 here, 58. And 1, 4, 8. Okay. You can do it this way. I do want to share a little trick on arithmetic because this question is quite routine. If you ever want to check your arithmetic and you want to make sure that you didn't make some sort of mistake in figuring this out, when your number is very close to a number like 30, you can use this nice observation. If I draw a square, which is 29 by 29, and as you can see, there's an extra 1 out here. Then I can see what the difference is between 29 squared and 30 squared. The difference is all of these extra squares around here. And the number of the extra squares is 30 along this way and 29 along that way. So altogether, 59. There are 59 extra squares in this strip. Notice that 59 equals 29 plus 30. It's a nice fact that between two consecutive perfect squares, the difference is just the sum of the two numbers. So I'm just going to remind that if I have 29 squared, and then if I add 29 and 30, then this is 30 squared. This is actually how I check my arithmetic, because when you're doing a problem, it's not very much fun when you know how to do it, and the only reason you have it wrong is some small mistake. I'm trying to help make sure that doesn't happen to you. Well, since I know this, I want to know 29 squared. I know 30 squared, that's 900. So I can try subtracting 59. And if I subtract 59, then I get 1, 4, 8. Good. So it's 841. I did this twice, actually, so that you're staring at 841 twice. 841 is a very special number. that I want to share with you another fun thing about 841. It has to do with other perfect squares. So remember I said that it was easy to do 30 squared. There's another easy square called 20 squared. It's 400. There's this 29 squared, which I just wrote down, which is 841. Do you know what is 12 squared? Yes, 12 squared is 144. Wait, that's not fair. What did I just do? I told you that 12 squared is 144. I wrote it backwards. Well, actually, what is here is true. And the reason it's true is because if you imagine what you're doing, when you multiply 12 squared, 12 times 12, you get 4. This is the 4. Let me do two multiplications at the same time. 21 times 21. I will do it in this way. This is the 4, and I'll use different colors. This is the 4. This is a 2. And over there, let me use some more colors. So here is a 2, and here is a 1. Okay. But I did that on purpose, because now I'm going to say, how did this 1 come? It was from there. That's this one. There should be a 2. So how did this 2 come from? It came from there. Let's put this 2 here. How did this 2 come? It was those 2, which is these 2. And here, 2, 2 is 4. So what you actually see is that the exact same numbers came out. 144, 441. This is a nice thing that happens because there was no carrying. Okay, but I wrote all of this like this on purpose. This is true. 400 plus 441 is 841. So actually I chose 29 squared because in every problem I do, I want to show you a method, and I also want to teach you something about a number. 841 is 29 squared. And that means that there is actually a right triangle from this Pythagorean theorem. There's a right triangle which has sides 20, 21, and 29. This is one of the rare right triangles that is hard for people to remember sometimes because it's not 3, 4, 5. And all three of the numbers are big, and they don't even have common factors. So, in case you ever come across something like this again, you will recognize that that's a right triangle that you can use somewhere. And as you play with your numbers, you'll recognize 841 as another friend.